Hey everybody, Justin here. I appreciate you checking out this video. In this video I want to do a quick kind of like impromptu video on sample space for probability. So say you have two dice, okay, and they're labeled 1 through 6, just a standard dice, right? Equal kind of chances of landing on each side. So one of the things that's cool about probability, or frequentist probability, is you have this notion of a sample space. This is the collection of all possible outcomes you can get with some experimental setup. So down here, going down this column, I have the first die, right? Dice 1, I just call it. And going over this side, I have, dice 2. You can get 1 through 6 also. And say you're asking questions of, like, what is the probability the dice, sum to the number 6? Well, you can actually enumerate all the possibilities. You could get, on the first dice, you could get a 5, and on the second dice, you could get a 1, and so that sums to a 6, okay? Or you can get a 4 on the first die, and then a 2 on the second die, and that sums to a 6, and so forth. So you can actually write out all the possibilities, and if you count them up, there are 36 total possibilities of outcomes, but the ones that sum to a 6 is just 1, 2, 3, 4, 5. So the answer is 5 out of 36. So that's a very powerful and also very simple idea. Now, can you do this for all possible kind of probability statistics problems? Probably not, or you can in theory, but outside of simple situations it's very difficult. Conceptually, it totally works, but practically speaking, like if you have an experiment and you're looking at people with a certain disease and medicine and so forth, I mean, writing out the sample space more than a theoretical way is not very practical, okay? But the idea works, and in simple cases like this, it's totally easy to write it out. So, but anyways, just wanted to share that idea, and some other ones you can do. I have some down here that I was doing with my son. Say the probability that the sum to a 7, well, you have, again, 36 possibilities, and if you count the number 7s, 1, 2, 3, 4, 5, 6, 6 out of 36, which is the same thing as 1/6. You can do probability sum is 2, which you only have, if you look at the table, 1. It only happens one time out of 36. That's if both dice are 1. Okay. And probability of sum equals 10. You have 3 out of the 36, or 1/12 is the probability. Okay. How about the probability they sum to 13? Well, nothing there will sum to 13 because you don't have that large of numbers on each dice, so the probability is 0 out of 36, or 0. So, but anyways, I just want to share this very simple idea called the sample space from probability. So I appreciate you checking out this video, and I'll see you next time. Bye-bye.